Today we're talking about section 10.6, which is on secant, tangents, and angle measurement. So, what is a secant? Well, a secant is a line that intersects a circle at exactly 2 points. So, right here in our circle C, J and K are examples of secants because they both intersect circle C at 2 points. Now, theorem 10.12 tells us that we can find any angle made up by 2 secants. And what we do then, to find angle 1, is we take AB and DC and we add them up and divide by 2. So you'll see right here, half of AB plus CD. So you just find those two, add them up, and divide by 2. The same also works with AB and BC. You add those two together, divide by 2, and that's angle 2 right there. So let's look at a couple examples. So the first one, if we're finding the value of x, okay, x is right here, we need to add 130 degrees plus 84 degrees, okay, which would be 214 degrees, and then we divide that by 2, which in the end is going to be 107 degrees. So what is x? X is 107 degrees. Now in letter B, I don't know what B, D, and AC are. I don't. But what I do know is that AB is 143 and CD is 75. So 143 plus 75 is going to be 218. Now why does the number 218 help me? Well, what it means is in a full circle it adds up to 360. So what I can do is I can take that 360 that I know the whole circle is and subtract 360 from it. So 360 minus 218, 142. So that means that AC and BD are going to have to add up to 142 because in a circle it always has to add up to 360. So I take that, divide it by 2, and I find that it's 71 degrees for angle X. Example C. Now example C is a little bit different. They tell us that the angle measure right here is 110. And that's going to be half as much as this GHX value plus 97. Okay? So if I'm going to solve this like a algebra problem, half times x, half times 97. So 110 is equal to 1/2 x plus, and then 97 divided by 2 is going to be 48.5. Okay? So what I would do then is I'd subtract 48.5 from both sides. Okay, so 110 minus 48.5, and I find that 1/2 x is equal to 61.5. Now how do I undo multiplying by 1/2? Divide by 1/2, or multiply by 2. And I find that x is going to be equal to 123 degrees. So we can do it both ways. We can find the angle formed by 2 secants, or we can find the arc formed by 2 secants if we know an angle on the other side. So here's a couple guided practice problems. You can do those right now. The next theorem we're going to look at is theorem 10.13, which says that if a secant and a tangent intersect at a point of tangency, so like this would be point A, then the measure of each angle formed is 1/2 the measure of the intercepted arc. Meaning that A right here, angle A, is half of that. Angle 2 right here is half of BCA. So let's look at this one right here. In example A, or example 2, letter A, we're looking for the measure of QPR. So I'm looking for this angle right here. Well, our last theorem, 10.13, says that it's going to be half of 148. So all I have to do is 1/2 times 148. And that's going to be 74 degrees. In letter B, we go the opposite way. They tell us that the angle right here is 64, and our job is to find this intercepted arc right here. Now that might be a little confusing because we don't know that angle, but we do know that this side right here, okay, arc FD, is going to be twice as big as 64, which in our case would be 128. And remember what I said earlier, that all circles add up to 360. So I'm just going to take 360 minus the 128 of the arc we do know, and that means that DEF is going to be 232 degrees. Again, those are some guided practice problems you can try now. Theorem 1014 says if two secants, a secant and a tangent, or two tangents intersect at an exterior angle, then the measure of the angle formed is 1/2 the difference of the measure of the intersected arcs. Okay? So, if I look at this example right here, the measure of angle A right there is going to be half of the difference between those two. So I'd subtract them and take half of it. Same with right here. Okay? I would take BC minus BC and take half of that. Same with right here. BBC minus BC and half of that. So in our case right here, let's find the measure of angle L. Okay? Well, if I'm looking for angle L right there, okay, I know that HK, arc HK is 102. I can figure out that HJK is going to be 360 minus 102. That's 258. And so angle L is going to equal half of 258 minus 102. Okay, so that's really half of, well, 258 minus 102 is going to be 156. So half of 156 is 78 degrees. So angle L right there is going to be 78 degrees. Just like we've done in previous examples, if I know the angle, so in our case 56 degrees, angle A, is equal to 1/2. The big side we don't know. Okay? We don't know what that is. So we're going to call that x. This value of arc BC is x. Minus 95. Okay? Solve it like an algebra problem. 1/2 times x and 1/2 times 95. So 56 is equal to 1/2 x minus 47.5. Add 47.5 to both sides. And I get 1/2 x is equal to 103.5. Okay? How do I undo multiplying by 2? I divide by 2, or multiply by 2. And I find it to be 207 degrees. So again, you can go both ways. If you know the angle, you can find an arc. If you know the arcs, you can find an angle. Here's a couple guided practice problems you can try now. Alright, so let's take all this and put it into a word problem. It says the diagram shows the path of light rays as it hits a drop of water. The ray is bent or refracted at points A, B, and C. If arc AC is 128 and XBY, right here, is going to be 84, what is angle D? Okay, so it's just like our last example. The angle D is going to be half as big as the difference between the two arcs. So what we're going to do is we're going to say, well, angle D then is going to be equal to half the difference between 128 and 84. So 128 minus 84 is 44. So half of 44 then is going to be 22 degrees. So angle D right here is 22 degrees. So to finally end our notes here, we have all of the circle and angle relationships that we've talked about. Okay? Any angle across from an arc is half, the measure of the angle is half the arc. Inside a circle, okay, we said that angle 1 right here is going to be half as big as the two of them together. And outside a circle, it's going to be half of the difference between the two angles. And this is in your notes, and it will come in handy when it comes time later to look at